So to find the density of irregular solid, it depends on the size of the irregular solid. So if it is a small irregular solid, like it can fit in the measuring cylinder, so in that case, what we can use a measuring cylinder simply. So what we'll do, we'll fill the measuring cylinder with liquid. Then we add the object into a measuring cylinder. The level of the liquid will change. How much there is a change in the level of the liquid, that is same as the volume of object, because like how much liquid displaced, that is same as the volume of object. But sometimes the object is big enough but does not fit into this measuring cylinder. So in that case, we can use a Eureka can, which is having an opening. So first we fill this can till the level, as you can see, till this level we fill, and we place a measuring cylinder next to this. When we add the object, the water will spill or come out from this Eureka can, and it will fill up this measuring cylinder. So how much the water come out, that is same as the volume of the object. So using a volume, mass and volume, we can work out the density of irregular object which is large and does not fit in directly into a measuring cylinder. Is it clear? This already we did the example. Then again the repetition is there. Density of aluminium, iron, brass, wood, slate. Now to find the density of the liquid, how we can work out the density of the liquid? For liquids, we have to keep them in a container, because the liquid cannot be placed without a container. So first what we do, we find the mass of empty measuring cylinder. Like example, this empty measuring cylinder, a measuring cylinder which does not have any water, that mass is 25 gram. Then we add a certain volume of the liquid. You can see it is filled with the liquid now, 20 cm cube of liquid, and we'll find the measuring cylinder, mass of measuring cylinder. The new mass is 45. So how to get the mass of the water inside the measuring cylinder? So originally the empty was 25. The empty measuring cylinder is 25 cm cube, and the filled measuring cylinder is 45. So what is the mass of the water inside the measuring cylinder? If original mass empty of measuring cylinder was 25 grams and the filled measuring cylinder is 45. So what is the mass of the water inside the measuring cylinder? So when we calculate the difference, so mass of the liquid will be equal to mass of a measuring cylinder and liquid minus the mass of empty measuring cylinder. So in that case it will be 20. Then how to calculate the density? We have the mass and we have the volume. So mass divided by volume, we will get the density. Is it clear how we can work out the density of the liquid? So for liquids, first we have to measure the mass of the cylinder, measuring cylinder or any container. Then we have to measure the mass of container with liquid and subtract the two masses to get the mass of the liquid. And mass of the liquid divided by the volume, we will get the density of the liquid. Is it clear? Then using a density, we can also identify whether the object will sink. Look, we are finding the density of the liquid. First what we did, we measured the mass of empty cylinder. The mass of the empty cylinder is 25 gram. So this mass of the empty measuring cylinder is 25 gram. Then what we did, we fill it with water. We fill it with water and the volume of the water which we add is 20 cm cube. So that is the volume of the water which we add, and that is 20 cm cube. Then when we measure the mass again, the water plus measuring cylinder, it is 45. So what is the mass of the water inside? When you subtract the two, so mass of the liquid inside is equals to mass of measuring cylinder and liquid, which is 45, minus the mass of empty measuring cylinder, which is 25. So when you subtract the two, 45 minus 20 is equals to 20 grams. So mass here is equals to 20 gram, and the volume which we add, that was 20 cm cube. So mass divided by volume, or 20 divided by 20 in this example, equal to 1 gram per centimeter cube. But in exam, you have to write the procedure. You don't have to use these numbers. The numbers are here just to explain the idea. Is it clear now? Then using a density, what we can do, we can also identify, using a density, we can also identify whether the object will sink or float. So how we identify if object density is less than or equal to the fluid density, that object will float. And if object density is more than the fluid density, that object will sink. So using the density, we can identify whether the object will float or it will sink. Example, you have in a room, it is filled with air. So there is a room which is filled with air, and inside the room you have a balloon, two balloons. One is filled with helium, another balloon is filled with carbon dioxide. I'm not writing full carbon dioxide, I'm using the formula for carbon dioxide, which is CO2. So when we work out the density, when we compare the density of the air in gram per centimeter cube, so it is air is a fluid, and the density of the air is 1.2 kilogram per meter cube, and the density of helium is 0.0001785 kilogram per meter cube, and the density of the carbon dioxide It is 1.98 kilogram per meter cube. So these are the densities. So we have air. Air is a fluid here because the whole room, the thing which can flow, air can flow from one place to another. So air is a fluid here. So in this example, we have air, which is a fluid, and we have two balloons. One is filled with carbon dioxide, another filled with helium. And we release the two balloons from the same height. What will happen to carbon dioxide balloon? Will it rise, go up, or it will come down? Will it float, rise, or it will sink? If I release the balloon which is filled with carbon dioxide. So because the density of the carbon dioxide is 1.98, is higher than the air, so it will sink, so it will move downward. And if I release a balloon filled with the helium, because when you check the density of the helium balloons very common. So why they float or why they rise up? Because their density is lower. As you can see, compared to air, their density is lower. So that's why the helium balloon will float or it will rise, where the carbon dioxide balloon will sink. So using the density, we can work out whether the object will float or object will sink. Is it clear, the concept of floating and sinking? And this is valid in case of water as well. Like we can have a container which is filled with water, and you can identify whether the object will float or sink by comparing the densities. So when you compare the density of the air with density of helium, because helium density is less than air, so that's why helium will rise. But when you compare density of air with carbon dioxide density is higher, so it will sink. And another example, same thing, this was in case of air, but we can also take for water. So you have a container which is filled with water. The density of the water is 1000 kilogram per meter cube. Or in gram per centimeter cube, it is 1 gram per centimeter cube. You have three objects made up of different material and they have different densities. The density of object A is 2 gram per centimeter cube. The density of object B is 0.5 gram per centimeter cube. And density of object C is 1.3 gram per centimeter cube. What will happen to object A? Will it float or sink? For object A, here water is the medium for us. Water is a fluid. Density of the water is 1 gram per centimeter cube. And density of this object is 2. So its density is higher. So what will happen? It will sink. What about object B? Its density is lower. So it will float. What about C? Its density is also higher. So it will also sink. So object A and object C will be underwater, and object B will float on the surface. So A, B, and C. So basically using a density, we can identify floating and sinking of the object. So how to find density of liquid, I will repeat again. So first what we do, we measure the mass of empty measuring cylinder. Like example, in this one it is 25 gram. Then we fill it with liquid. Say we fill it with 20 cm cube of liquid. Then we measure the mass again. The new mass is 45. So original mass was 25, the empty one, and the filled one is 45. So what is the mass of the water inside? The mass of the water which is inside is 20 gram, because the difference of the two will give us the mass of the water. And the volume of the water is 20. So mass divided by volume, what we will get? We'll get the density of this liquid. Now some questions related to the topic. Abdullah Sarfraz, look, first what we are doing, we want to find the density of the liquid. To get the density, we need mass and we need volume. So first what we did, we measure the mass of empty cylinder. So we place it on the balance and we measure the mass of empty cylinder. Say it was coming out as 25 gram. Then what we did, we fill it with water or a liquid which we are finding the density. So when we fill it with a liquid, say we fill it with 20 cm cube of liquid. This was 10, 20. So we fill it with 20 cm cube of liquid. And the mass is coming out as 45 gram. So what is the mass of the liquid? Because we want the mass of the liquid and we need the volume of the liquid. So what is the mass of the liquid? The mass of empty cylinder was 25 and the mass of filled cylinder is 45. So how I'll get the mass of the liquid? To get the mass of the liquid, I'll subtract the two masses. If I say this is M1 and this is M2, so to get the mass of liquid, it will be M2 minus M1. So it is 45 minus 25, which is equals to 20. So mass of the liquid inside is 20. And what about the volume of the liquid? When we read the measuring cylinder, the volume of the liquid is also 20 in this example. So the density is coming out as 1 gram per centimeter cube. Is it clear now? Yes, Abdullah?
Sir, we just see the markings on the balance.
No, not marking on the balance, marking on the measuring cylinder to read the volume. And we read the scale. When first we read the scale, that is 25 gram. So that is the mass of empty. And when we add water or a liquid, that is the mass of the filled. So how I can get the mass of the liquid inside? So I'll subtract the two masses, the filled minus the empty. So I'll get the mass of the liquid. And we just read the level of the liquid to get the volume. And mass divided by volume will get the density of the liquid. Is it clear now?
Yes, sir, clear.
So this is how we find the density of the liquid. Now some questions. The diagram shows a cuboid made up of metal which is having a density of 2.5 gram per centimeter cube. What is the mass of the block? The dimensions are given, length, width and height is given. So you have to work out the mass. What's the right answer? You can use screen annotation to state the answer. A screen annotation or a chat to state the answer. We need the mass of an object. mass is density multiplied by volume. This is a density given, and to get the volume, it will be length into width into height. So what appeared to be a right answer? So 2 multiplied by, what about others? I want participation from everyone. So 2 multiplied by 2 multiplied by 10. 2 multiplied by 2 is 4, 4 multiplied by 10, that's 40. And to get the mass, density is 2.5 and the volume is 40, so it will come out as 100 grams. So the correct answer is D. Another question, a measuring cylinder containing 30 cm cube of a liquid. Some more of the liquid is added until a liquid level reaches 50. The reading on the balance increases by 30. What is the density of the liquid? A, B, C or D? Abdullah Khan, Saim, I want your participation as well. Density is mass divided by volume. The measuring cylinder was having 30 cm cube, so some more liquid is added. We add more liquid into it, and the level reaches 50. So new level is 50. So what is the volume of the liquid added? That is 20. And what is the mass increase? 30. So mass divided by volume will get the final answer. Then the correct answer is C. So why C is the right answer? As you can see, a measuring cylinder contained 30 cm cube of liquid. So it was having 30 cm cube of liquid, but they did not mention what is a mass. Then some more of the liquid is added until the level reaches 50. So we add more liquid until the level reaches 50. So how much volume is added? What volume we add? We add 20 cm cube. And when we add this 20 cm cube, how much the mass increase? The reading on the balance increases by 30. So the mass of this 20 cm cube is actually 30 grams. So how to get the density? Density is mass over volume. So 30 divided by 20, that's equal to 1.5. So C is the right answer. Is it clear to everyone? Is it clear? From where I got 20, as you can read the question, they mention here, Abdullah, that a measuring cylinder contains 30 cm cube of liquid. So this measuring cylinder is having 30 cm cube of liquid. Then what we did, some more of the liquid is added until the volume reaches 50. So when some more of the liquid is added, the volume reaches 50. So how much liquid is actually added? Original volume was 30 and the new volume is 50. So as Bisra mentioned here, the final volume is 50 and initial is 30. So when we subtract the two volume, we'll get 20 cm cube. So basically 20 cm cube of liquid is added. And what about the mass? They mentioned the reading on the balance increased by 30. So the mass which is added or increased, that is 30 gram. So mass of this 20 cm cube is 30 gram. That's why the mass increased by 30. And to get the density, the mass of the liquid divided by the volume, you will get the density of the liquid. Is it clear now? Another question. A solid ball has a volume of 4 cm cube. The density of the ball is 1 gram per centimeter cube. What is the mass of the ball? the mass of this ball. Saim, you're not responding. Saim, Muhammad Hatim. You can use the chat if you're not able to use the screen annotation. Abdullah Khan, Lamia. So the correct answer is D. How D is the correct answer? We have the volume and we have the density. So the mass is actually the product of density and volume. Another question. A measuring cylinder contains 40 cm cube of water. A solid metal is dropped into a water and the water level rises to 56. The mass of the ball is 80. What is the density of the metal from which the ball is made? Or basically the density of the ball. So the volume of the liquid, that's the difference, 56 minus 40, that's equal to 16. And the mass is 80, so 80 divided by 16, that's equal to 5 gram per centimeter cube. That's right. Another question. A small bottle has a mass of 20 gram when empty. So this is a mass of empty bottle. The volume of the bottle is 10 cm cube. So it can have 10 cm cube of the liquid. When full of liquid, the total mass is 150. What is the density of the liquid? Empty bottle is having a mass of 20 and the filled bottle is having a mass of 150. And the volume of the liquid inside is 10. What is the density? First, you should get the volume mass of the liquid. So when you work out the mass, this is empty bottle. So this is empty, it's having a mass of 20 grams. And when it is completely filled with a liquid, the mass of the filled one is 150. So when you want to find the mass of the liquid, you subtract them. So it will be 150 minus 20, that's equal to 130. So mass is 130 and the volume is 10. So 130 divided by 10, 13 gram per centimeter cube. So C will be the right answer. Don't bother about the wrong answer because it's important that you try to answer these questions as is a preparation. It's not a test or exam. So you learn from your mistake or identify or rectify your mistakes. Another question, the mass of a measuring cylinder is 190 and 40 cm cube of liquid is poured into a measuring cylinder. The total mass of a measuring cylinder in the liquid is 560. 4 solid objects are lowered into the liquid. The density of objects are shown. Which objects will float in the liquid? But to get, first we should know the density of the liquid. How to get the density of liquid? It's mass of the liquid divided by volume. So what is the mass of the liquid? It is 190 is the empty cylinder and 560 is the filled. So 560 minus 190, that is 370. So 370 is the mass and the volume is 400. So 370 divided by 400, that's equal to 0.92. So 0.92 gram is the density of, gram per centimeter cube is the density of the liquid or the fluid. And we add these objects. The question is how many objects will float? When we place object 1, because its density is lower, so it will float. Object 2, float. Even if it is 0.92, it will also float. Because the density of object should be less than or equal to density of the fluid. So this is 0.92 and this is 0.9, so it is less. That's why this will float. This will sink, this will also sink. So B will be the, yes Abdullah?
Sir, if an object has the same density as
That
a
also float.
liquid,
If it is 0.92, that also float.
okay, sir.
If it is more than 0.92, like example 0.93, then it will sink. So 1 and 2 will float and 3 and 4 will sink. Solve this question. You can use the screen annotation. It's a tricky question, but I do expect that you can solve this. We are finding the density of the cork or lid. The mass of the cork is given 4.8 gram. Take your time to state the answer. Saim, I'm waiting for your participation as well. Saim, Mohammed Hatim. The mass is 4.8. We need the volume of the cork. Look, this is a volume of the water only. This is the volume of water and sphere or a ball. But we don't need the volume of the ball. The moment we add a cork, how much the volume changes? So it changes from 56 to 80. So basically this change in the volume from 56 to 80 is the volume of the cork. And we need only volume of the cork. So volume of the cork is 80 minus 56, which is equals to 24 cm cube. And density is mass in a unit volume. So mass of the cork is 4.8 and the volume of the cork is 24. 4.8 divided by 24. So B will be the right answer for this. Is it clear? Why we did not bother here? Why we did not consider this change? Because this change is actually the volume of the metal sphere. But we don't need that ball or a sphere. We need the density of the cork. So to get the density of the cork, we need the volume of the cork. Is it clear to everyone? The moment we add a cork, the volume change, and that change in volume is equal to the volume of the cork. Okay, in this question, we have to calculate the weight of a piece of glass. So how we calculate the weight? The density of a glass piece is 2.6 into 10 to the power 3. area is given and the thickness is given in centimeter. If area is given in meter, so this should also be in meter, because how we can find a volume? Volume can be length multiplied by area as well. So length is given in centimeter, we have to convert into meter. So we'll divide by 100, so it will be 0.02 meter. To get the volume, length is 0.02 multiplied by area 0.15. So we multiply this 0.02 multiplied by 0.15, that will give us 0.003. So 0.003 meter cube. That's a volume. First, we'll find the mass. How to find the mass? Mass is density multiplied by volume. Density is 2.6 into 10 to the power 3. So 2.6 into 10 to the power 3 in a scientific calculator, you can substitute that exponent. I already mentioned how to use a scientific calculator. So 2.6 exponent 3 multiplied by 0.003, that will give you the mass. So mass of this coming out as 7.8 kilogram. But in the question, they're not asking for mass, they're asking for weight. So how to get the weight? Yesterday we used a formula, weight is equals to mass multiplied by gravity, and on earth the gravity is 10. So 7.8 multiplied by 10, what you will get? You will get as 78 newtons. Is it clear? First, the volume is length multiply width multiply by height, or length into area. Because area is given in meter square, so length should be in meter as well. If area is given in centimeter square, so then length should be in centimeter. Is it clear to everyone, this question? Look, length is given 2 centimeter and area is given 0.15. So when you multiply length with area, you get the volume. But length is given in centimeter. So first we have to convert centimeter into meter. That's why we divided by 100. So when we divide by 100, it will be 0.02. So length is 0.02 and area is 0.15. So when we multiply, we got 0.003 meter cube as a volume. Density is there and the volume, when we multiply, we get the mass, because mass is density multiplied by volume. So 2.6 exponent 3 multiplied by 0.003, we got the mass. And after getting the mass multiplied by gravity, which is 10, you will get the weight, which is 78 newtons. Is it clear now, Abdullah? So we completed this topic as well, which is about density. Topic 1.4. So we discuss definition of the density, how we use different formulas to calculate density, mass, and volume. And we discuss experiment to find density of regular and irregular solid, and density of a liquid, as well as predicting whether the object will sink or float.